Dear guests, welcome to the 12th International HVACR and Sanitary Technology Symposium. The purpose of the symposium is to bring together the engineers, designers, researchers, contractors and academicians working in HVACR and sanitary engineering field to discuss and share their scientific and technological developments and new designs issues of various aspects of the Prof. Symposium's main theme is Widen Your World for the Efficient Solutions. Now for the opening speech, I would like to invite Professor Dr. Nilüfer Eğrican, President of Executive, Organizing and Scientific Board.
Good morning, dear colleagues and distinguished guests. On behalf of Executive, Organizing and Scientific Board, I would like to welcome you to Istanbul for the 12th International HVAC Plus R and Sanitary Technology Symposium. This three-day symposium, coupled with boat cruise and gala dinner, will provide an efficient and at the same time a productive knowledge exchange platform for scientists and engineers from all over the world. Besides the opening section and lecture with Dr. Brajne, Olesen, I hope I pronounce well, from Technical University of Denmark, highlighting the symposium, there are 9 keynote lectures given by Wei Sun, ENG Cisco Incorporated, and Dr. Michael O'Hady from University of Maryland, Dr. Eckhard Grohl from Purdue University, Dr. Branislav Todorovic and Dr. Maria Todorovic, both from University of Belgrade, and Nejat Babür from Enel Corporation, and formerly STV and CH2M Hill from United States, and Dr. Sherif Ahmed Sherif from University of Florida, and Dr. William Warwick from Texas A&M University. Peter Water couldn't come because of his father's illness. He is in the hospital. He sends his best regards to all of you. There will be also 3 panel discussions, namely Turkish HVAC Plus R industry, building information modeling strategy in the first day, today, and tomorrow, widen your world for efficient solutions, thermodynamics, and the last day, design and planning in achieving successful buildings. We will discuss all matters which cover HVAC, R, and sanitary engineers during panel discussions. The scientific committee of the symposium consists of 28 members from different well-known universities. After a very intense evaluation and collection processes, 57 papers were selected to be presented orally in 15 technical sessions. Abstracts of all presented papers are included in the program abstract book, and all the full papers can be observed in the proceedings section of the USB provided for you, for the participants. This year, the scope of symposium topics are designated between sustainable and energy efficient built environment and emerging technologies that support such development. We will emphasize on sustainability of the built environment within a perspective from past to present and to the future. Main aspects of sustainable development, which includes economic, social, and environmental sustainability, are all covered within the scope of selective papers. Within our designated panels and technical sections, you will be able to find interesting and contemporary topics which would guide you to develop your own roadmap and business strategy towards the future. I believe we will have some enthusiastic discussions this year. If you are looking for what to do during the forthcoming decades to strengthen your business strategy and stay competent, you are in the right place. Welcome again, once more. Energy efficiency is the first step towards a sustainable development. We will elaborate on energy efficiency within the scope of the basic of life thermodynamics. You will get insights to the state-of-the-art scientific progress for active and passive solutions for the building industry. One other important thing I want to emphasize here within the scope of sustainability is the importance of water management technology. The amount of water is relatively small compared to many other resources available on Earth. According to the United States Facts and Features, 85% of the world population lives in the driest half of the planet. 783 million people do not have access to clean water, and almost 2.5 billion do not have access to adequate sanitation. 6 to 8 million people die annually from the consequences of disasters and water-related diseases. It is the duty of HVAC and sanitary engineers to develop sustainable solutions for the world. That's why our topic is here, widen your world for efficient solutions. We have to shift our industrial production techniques to stay competent. I believe our colleagues will discuss on new manufacturing methods which will help our companies competent within the approaching era. Last but not least, I would like to recall your attention to a new report the multi-layer market development plan published by the United States Department of Energy. Let this event be our kickstart to benefit from this enlightening research and develop our own for the future of the world. I would like to take this opportunity to thank Turkish Society of HVAC and Sanitary Engineers, TTMD, for organizing HVAC symposiums in a sustainable manner since 1994. Thanks to the past presidents of the society. They are all here, I believe. Really, I appreciate their presence. And also our president, Sarven Çilingiroğlu, he is here with us from the beginning to the end. I would like to take also this opportunity to thank keynote speakers for their valuable contributions. They are also here. Thank you very much for their presence. Authors for submitting their works, the scientific committee members for taking time and reviewing papers, Secretariat Ethics Incorporated, and mostly I would like to thank organizing committee members for making 12 International HVAC+R and Sanitary Technology Symposium a very highly successful conference, both technically and socially. I wish all participants a pleasant week during the symposium, and for our international guests, I wish you a favorable stay in Istanbul and in Turkey. I sincerely hope this will be a very productive and effective symposium for all of you, your participants. Thank you very much.
We thank you, Professor Dr. Nilüfer Eğrican, for her speech. Now, I would like to invite Mr. Sarven Çilingiroğlu, President of TTMD and Symposium Chair.
It's a little bit high. Good morning, dear guests, press members, and dear colleagues. As the president of TTMD, Turkish Society of HVAC and Sanitary Engineers, I would like to welcome you all to this symposium. At the beginning of my speech, I would like to give you some information about TTMD. TTMD was founded in 1992 to bring together the engineers who are working in the fields of heating, refrigerating, ventilating, plumbing, insulation, and fire safety to share their expertise. Currently, TTMD is one of the largest non-governmental organizations in Turkey, having more than 2,000 professional members comprised of designers, manufacturers, contractors, academicians, and sectorial policymakers. TTMD carries out many cooperations with universities and vocational schools, industry, research institutions, governmental bodies, sister non-governmental organizations, and other professional experts group for the objectives of creating environmentally friendly living areas that are utilizing energy more efficient and to incorporate more sustainable systems in installations. TTMD represents the Turkish engineers in international platforms and keeps contact with international professional associations, follows the technological developments and transfers them to its members. TTMD is also a member of EŞRE and RİHVA. In addition to the regularly organized seminars and courses, TTMD holds also workshop, symposia and congresses. Workshops are also significant activities of TTMD. Recently, the conceptual arrangement of TTMD annual workshop has been altered such that its topic, which happened to be smoke control and fire scenarios this year, is determined according to the demands and needs of designers, contractors, and sales representatives. After the workshop, the discussions made and conclusions reached have been published in a book. In order to inform the HVAC sector about this subject, we would like to thank Professor Abdurrahman Kılıç for this invaluable effort on this matter. Likewise, a second book titled as Combined Heat Power with Renewable Energy Sources has also been prepared and published before our symposium. Moreover, this book will be translated into English soon and will take its place among the technical literature of EŞRE. For this as well, on behalf of TTMD, I would like to thank the authors of this book, Professor Birol Kılkış and Şiir Kılkış. TTMD also publishes journals, guidebooks, and manuals containing update information and takes part actively in regulatory and standardization works. Being experienced as a partner in EU-funded R&D project, TTMD is adding value to the whole process from theory to practice. Heating and air conditioning are at the center of energy consumption in our world today. As the living standards improve and the demand for comfort increases, air conditioning is becoming indispensable. The need to find a sustainable solution for growing energy use has become ever more important. Achieving sustainable energy consumption is one of the major goals of developed societies around the world. Likewise, research on buildings for tomorrow has become increasingly popular and highly supported by many governments. The 12th International HVAC plus R and Sanitary Technology Symposium will address Widen Your World for the Efficient Solutions as its main theme. The symposium has received 84 abstracts from 11 countries. In addition to inviting world-renowned speakers at the symposium, we organized 3 panels titled Turkish HVAC plus R Industry Building Information Modeling Strategy. Second panel is Widen Your World for Efficient Solutions, the Importance of Thermodynamics. And third one, Design and Planning in Achieving Successful Buildings, where experts from different countries will share research expertise to broaden the scope of discussions. On behalf of TTMD, I would like to thank the organization committee and the head of the science board, Professor Nilüfer Eğrican, for their invaluable effort. Also, I would like to thank our partner sponsor, İSİP, Platinum sponsor, Alarko Carrier, Arçelik, and ODE. Gold sponsor, AFS, Bosch, Form, Honeywell, and Mitsubishi Electric. Silver sponsor Borusan Menesman, Daikin, Gelişim Teknik, Inkapam, Norm Teknik, Trox, Üntes, Wisman, and Vilo. I wish you all a very successful symposium and pleasant stay in Istanbul. Thank you very much.
We thank you, Mr. Sarven Çilingiroğlu. Now, we would like to invite Mr. Zeki Poyraz, President of TOBB HVACR Assembly and Chairman of Turkish HVACR Exporters.
Hayırlı sabahlar, günaydın. Good morning, everybody. Dear TTMD Chairman, Mr. Sarven Çilingiroğlu, dear Organization Committee President Nilüfer Eğrican, media representatives, dear President of Turkish associations, distinguished guests, HVACR and sanitary engineers and technical professionals. I would like to welcome you all. Dear guests, as a chairman of the Turkish Climatization Assembly and Exporters, I am very pleased and honored to address you on behalf of the Turkish HVACR and sanitary sector. First of all, I would like to express my gratitude to the committee for organizing this outstanding gathering, which is one of the Turkey's most important conference. Thank you, Mrs. Nilüfer Eğrican. This conference in the field of heating, ventilation, and air conditioning and sanitation. I am fully convinced that the Congress declarations, seminars, and the papers will be helpful in fulfilling the responsibilities assumed by the sector for a more habitable and sustainable world in the context of energy efficiency, noise pollution, and environmental problems. Dear guests, I would like to share some data related to our sector in Turkey. With dynamic and flexible structures, Turkish HVACR industry has managed to realize an 8-fold increase in last decade and ranks high in the production and export of many products. For example, Turkey is the world's top exporter of radiator and towel warmer products, has the biggest production capacity in Europe in split air conditioners, flexible air duct, and ventilation equipments. Turkish products are used with confidence in 185 countries worldwide. With the injection of foreign investments in the Turkish market, the sector has assumed a role that now market is a strong candidate both for becoming Europe's production hub and as a technology exporter. Our sector in Turkey is a center of attraction for international companies due to both its qualified manpower and strategic location. Global companies such as Atlantic, Baymak, Bosch, Carrier, Daikin, Ferroli, Grundfos, Johnson Controls, KSP Pump, LG, Ross, Shaka, Solar and Palau Group, System Air, Vylant, Wisman, Vilo have significant investment in Turkey. Turkey has covered considerable ground in the construction sector in past 2 decades. Many Turkish firms are among the sought-after brand names in international construction projects. Turkish construction sector ranks second in the global markets. Dear guests, our sectoral organizations are as follows: Bacader, Dosider, Euder, Günder, İzoder, İSKAV, İSKİT, ESİAD, SOSİAD, İSEDA, KBSB, MTMD, and TTMD. These are our sectoral associations that we are going to work with them closely. We believe that every association of the Turkish HVACR sector is important and has a specific role. We especially have a strong cooperation with the Turkish Sanitary Engineers Association. I mean TTMD. Our cooperation is not limited to Turkish associations. Our cooperation is not limited to Turkish associations. Turkish exporters attach great importance to the cooperation with international sectoral organizations as well. In this context, we give support to REHVA, Klimamet, ASHRAE organizations. Our cooperation has started with ASHRAE during RAL CRC 2014, continued with 2015, Chicago, RAL CRC Istanbul 2016, and Orlando Winter Conference 2016. I would like to say that I am extremely pleased with the outputs of said organizations as well. Besides its critical role in determining the sectorial standards, ASHRAE has a great structure, sharing knowledge, network, and communication and cooperation. We strongly believe that it has become a necessity rather than a luxury to work on an international scale. I would like to mention the importance of these specifications. This world does not belong to us. We owe it to our children, and protecting it is our duty. As I conclude my words, I wish you a good Congress and wish it to be beneficial for both our sector and the world. It is our honor to be the partner sponsor of this important event. Thank you and enjoy your stay in Istanbul. Have a good day, good seminars.
Dear participants, we thank you, Mr. Zeki Poyraz. Now we finish the opening session and we start the invited speakers session 1. I would like to invite the chairman of the session, Mr. William M. Borek, director of the Eagleford Energy Center at Texas A&M University.
Thank you. It's a pleasure to be here, and welcome to the invited speaker session number 1. It's my job to introduce our first invited speaker, Professor Olesen. Professor Olesen is a full professor in indoor environment and energy at the Technical University of Denmark and director of the International and Energy and Technical University of Denmark and director of the Center for Indoor Environment and Energy. He has received numerous ASHRAE awards and is very active in several international standard committees involving the indoor environment and energy and performance in buildings and HVAC systems. Please welcome Professor Olesen.
Thank you. Thank you for inviting me again back to Istanbul. It's always a pleasure to come back here. And today, this morning, I'm going to talk about zero energy buildings, what activities is done or planned, especially in Europe, but also in the US. My background for doing this is that I very much involved in the European standardization related to energy efficiency of buildings in Europe. And then in the US, at the moment, I have the position of Treasurer of ASRE, and I thank you very much for the nice word you said about ASRE before. It's always nice to hear. And we in ASRE are really looking at the global world. We are not an American society, we are a global society. And during my year as president, that will be even more visible. Now, there's a lot of talk about going to zero energy building. And some of the actions I'm going to talk about here is that we are working with building codes and standards. That's some of the drivers towards zero energy building. I will talk about the European Energy Performance Directive, but we also see requirements to use more renewable energy because people, even a zero energy building is using energy, but it has to use renewable energy. Then it can be a zero or net zero energy building. And we will also see that there's activities to do requirements, not to the buildings as a whole, a holistic approach, but also to products and components. So the manufacturers, they are doing a lot also to decrease the energy use of their products. Now in Europe, the building sector is a very important part of the total European economy. 40% of EU's energy use is for providing good indoor environment in buildings, and is responsible also for about 40% of the CO2 emission. But we still think in a cost-effective way, and this is important, cost-effective, that there's still a potential for doing savings. So there has been set up now some directive to increase the saving of the energy and reduce the energy use. In European activities is very much guided by the European Union. And to get a little understanding on the European Union, I have tried to show it up here, that we have the European Parliament, which are really elected by the people in the different European countries, and then we have the representative from the different governments in the Council of Ministers. And the Commission is the one who is really doing the administration. And they have been for years working on how can we improve the energy efficiency. And they do that by setting up what we called a directive and policies. And that has then to be implemented in the national building regulation and the national building codes. So for some years ago, they set up the policy called 2020 that we should decrease the greenhouse gas level with 20%, increase energy efficiency or decrease energy use with 20% compared to 1990. And we should have at least 20% of renewable energy in the total energy mix. Now this has been recently been looked at again. So now the future goals for 2030 is a reduction of 40% of greenhouse gas levels 27% decrease of energy use, and an increase of the renewables in the energy mix up to 27%. If we will make it, there's of course no guarantee, but the prediction says that it will be possible, also in a cost-effective way. Now, the requirements for the reductions of energy use in Europe, it's not the same for all countries. We know we have different possibilities, and for example, countries like, if you look up here, like my own country, oh, sorry, just go back again, Denmark. We have been very good at saving energy. We don't have any energy sources ourselves, like fossil fuels and so, but still they expect that we should be able to save even more energy than we are. While other countries, we know there's a lot of development going on, especially in the eastern part of Europe, so there we in fact expect that the use of energy will increase. So it's not like all countries will have a decrease in the energy use. They will be different depending a little on the potential for the different countries. Now, one of the tools that is being used is the directives. So when the European Commission set up a directive, that requires the implementation in the national building codes. And one of the important ones I will talk a little more about is the Energy Performance of Buildings Directive, which was first issued in 2003, and it has just been remodeled. There's also a directive I'll talk about called Eco-Design, which is setting requirements to the individual component. But what they do, for example, they say with the Energy Performance of Buildings Directive, they are not requiring each country put a requirements to what is an acceptable energy performance. But they're requiring countries that they have to set up a method to evaluate the energy performance, to calculate it, and there must be a national requirement. But the national requirement can be different from country to country. Now, one of the directives is requesting the countries to use more renewable energy. And again here, the expectations are different for different countries. Also because when you look at the energy mix in different countries, it's quite different. If, for example, you look at Sweden, in the electricity production in Sweden, is almost half of it is by hydropower, another half is by nuclear, and a small 10% is by biofuels. So they really don't use any fossil fuels. So when we use a primary energy or CO2 emission in Sweden, it's very low. Where other countries are using more, like for example, Netherlands are using a lot of natural gas and also coal. So it's quite different how the different countries, what the energy mix is in the production, especially of electricity. And the expected use of renewable sources, you can see what the expectations are here. From 2005 to 2020, it expected that Denmark will increase its part from 17 to 30%. Germany are relatively low on renewable, but that should increase up to 18. Where you see Finland and Sweden, partly because of the hydropower, already have a very high part of renewable energy, but we are still expecting that they can do more on renewable. while other countries, there is a difference. They have more difficult in having renewable energy sources. So when, for example, the requirement is that by 2030 we need about 27% of the energy mix should be renewable. It's an average value. It's not a value for each individual country, but it should be on the average for the EU. When we look again here in Denmark, the renewables we have in Denmark, in 2009, you see major part when we produce our electricity was fossil fuels. It was natural gas, but also oil and some coal. And we had about 19% of wind turbines, energy from wind, and biomass. We have a lot of activities to increase the part coming from wind turbines up to 42%. So we are building a lot of wind turbines. Some years ago, when we had the first wind turbines, people thought it was nice to see a wind turbine, but they don't think that anymore. Nobody wants to have a wind turbine close to their house. So the future wind farms will be offshore. Very few we will see now inland. It will mostly be offshore wind farms. Now, when we look at one of the other directives for the design, then we will see that here the question is now setting up requirements for the energy using products. So there's many activities that already exist, several eco-design for boilers and water heaters, room air conditioning, fans. All the different components are being looked at to see what basic requirements can we put to the energy efficiency of these products. So that's something which are very important for the manufacturers of products. But it doesn't guarantee, of course, that the total buildings will have a good energy performance, but that's the first step. So at the moment in Europe and also in the US, they're setting up requirements to increase the efficiency of energy using products. EU has also a big research program where a lot of the topics is dealing with energy efficiency. So the research program is also one way of increasing the knowledge, getting new tools to work in the direction of low energy buildings or zero energy buildings. Now, the most important directive for the energy performance is the Energy Performance of Buildings Directive. It was first issued in 2003, and one requirement was that each member state, they should have an integrated methodology to rate the energy performance of buildings. So they should set up a method to calculate the energy performance of a building. They should also put up a minimum energy performance standard. So they should have in their building code some minimum requirements to what is an acceptable level of energy performance. But this level of energy performance could be different from country to country, as I will show in a little while. Each building must have an energy performance certificate. And that means every time a building is changing hands, they need to renew the energy certificate. This is something we have had in Denmark since in the 90s, and really the Danish model was used to make the European model for energy certification. But also there was requirements to inspection of boilers and air conditioning systems, because we know One thing is how it performs when it's new. We know it will deteriorate. You have to have maintenance. So there has also been set up requirements in the different countries to do inspections. Now, the reason why they ask now all countries to have in the building codes requirements is that you have seen from different countries, for example, here in the Netherlands, that each year when you increase the requirements, that's the energy performance, a lower value have a higher energy performance and less energy use. The requirements, national building codes, will year by year lower the energy use in buildings. And we see the same trend. Here's the Danish, Norway. All these countries have for many years had building codes with requirement. So building codes is a very efficient way of forcing people to make better buildings and more efficient systems. And now this is implemented in all the European states. Well, then recently this was revised, and there zero energy buildings was introduced. It was required that by 2021, 2019, that we should have nearly zero energy buildings in all European countries. What is nearly? I will come back to that. You will notice that it didn't say zero energy buildings, it said nearly, which has caused a lot of problems. But it has to be cost optimal, so you should look also what would the cost be to make a zero energy building. Then also they realized that the use of these performance certificates and inspection was not well implemented in all countries. They wanted to put more emphasis on it, and you must do it. You cannot give a building permit if there is no evaluation of the energy performance. So regarding these zero energy buildings, or nearly zero energy buildings, the requirement is that by end of 2018, new buildings occupied and owned by public authorities, they must be near zero energy building. So they want the public authorities to go in front and show how you can make zero energy buildings. And then from 2020, all new buildings should be nearly zero energy buildings. So, and also the member states shall develop a national plan for increasing the number of nearly zero energy buildings, including a detailed application of the definition in practice. So how do you define nearly zero energy buildings? And the very important is that the member states shall also develop policies and take measures to stimulate energy refurbishment into nearly zero energy buildings. Because if you don't do anything with the existing buildings, it will take many years before we can go down to zero energy buildings in general. So zero energy buildings concept mainly means that the energy you use for space heating, pumps and fans, space cooling, lighting, and hot water should be the same as the energy you provide by natural means. So no fossil fuels are used. There's some discussion about appliances or plug loads, if they are included or not. Some countries have included these. Others only have hot water, lighting, space cooling, pumps, fans, and space heating. So in the recast, it was first said the Commission wanted that people should make zero energy building. But the countries said it was too strict. It was very difficult to go all the way to zero. So as a compromise, they introduced what they call nearly zero energy building. But then each country had to define what is nearly. Well, it has a very high energy performance, but how close is nearly to zero? And that was the individual countries that could specify that. So when we, I'll just skip this. Now go to this zero energy building. It's very clear. It is a building with the energy performance of 0 kilowatt hours per square meter per year, primary energy use. So it's primary energy use. But nearly zero is now not so clear. And when we now look at how it has been defined in different countries, you will see here there's quite some differences. If we look at the requirements in Denmark, this over the building regulations in 2006, 10, 2015, we have just made a new one, where the energy requirements is basically divided in residential and non-residential. And the requirements is in kilowatt hours per square meter per year. Primary energy is related to the surface ground area of the building also. But the way we have defined in the future 2020, and that's our definition of nearly, that's 20 kilowatt hours per square meter per year for residential, and non-residential 25. And non-residential is independent of if it's hospitals, if it's office, or whatever commercial building it is. So when we then look at another country like Estonia, again, it's based on primary energy requirements. But what they define as nearly zero energy building, it's split up in office, apartment, and detached houses. They are talking about 50 to 100 kilowatt hours per square meter per year. So this, introducing this word nearly, caused a lot of discussion in different countries. How do we define it? And personally, I think it was not a good idea. That caused a lot of confusion. Another thing is, when you do now the total balance of the energy, what is being used, what is being produced of renewable on-site or nearby, and what is produced at a distance or at the source, for example, at the power plant. Here, for example, most countries are saying that it should be near zero based on primary energy for on-site production of renewable and nearby, and not including source energy. And you can discuss what is correct. Should you include source energy or not? If you want to put emphasis on the individual building and have that to be zero energy based on primary energy, then you should not include source energy. Because you can have, for example, in Sweden, you can have a very lousy building, but because they don't use any fossil fuels, the primary energy is almost zero, you can still heat and cool this building and be zero energy. So this discussion has gone on. Should it be on-site nearby production, or can also include the source production? I will come back to that when we look about the US. Now, to help the countries having a methodology to calculate the energy performance of buildings, the European Union asked CEN, it's the European Standard Organization, to set up a set of standards so that the countries can use them to calculate the energy performance. So there was an overarching standards, and then there was about 50 standards which are dealing with the different parts of the system. So it was based up like a module, so each standard, for example, one dealing with heating system, one ventilation system, cooling system, lighting system, building and building elements. So there were different modules, and that's why it was split up in different standards. if we look at the concept, the calculation procedure is like you start finding out what is the demand now for, if we take on a heating system for heating, what is the demand of the building? How much energy do you need to put into the building to obtain a certain indoor environment so you have a comfortable condition for the people? And there you take into account solar energy, passive solar, transmission losses, ventilation losses, and also internal loads from people. So you find out what is the demand. So this is a system-independent value. It's only depending on the building. And now you start looking at the building. What is your heat emission system? Do you have a floor heating? Do you have radiator? Do you have warm air heating? We know we cannot control that perfectly, so there are losses in the emission system. In the distribution, you have auxiliary energy for pumps or fans, which are calculated, and you also have losses, and the same for storage and generation. So you go through the system and end up with values for how much electricity you need and how much thermal energy, and then you convert to primary energy. And again, the conversion to primary energy, the energy factors, are decided by each individual country. It's not something that the EU prescribes, that's individual countries. So again here, we see some of the primary energy factors are not technical factors, they are political factors. For example, in Sweden, which has almost no fossil fuels, they could put the primary energy factor almost to 0, but they still put it on electricity around 2, because they don't want people to use direct electricity for their heating. They want to use it through a heat pump. This is a very busy slide, but that gives a structure where you have all the different standards which are now developed. The standard calculating the demand, and then you see what do the cooling system, ventilation system, heating, domestic hot water, and lighting system. And input from standards for requirements to the indoor environment, climatic condition, building properties, and etc. So there is a whole set now. All the standards are almost finished. They will go out for the formal vote in the fall, September or October. But one thing with this, a lot of these standards are also being issued as ISO. EN ISO. So already 17 of these will be EN and ISO standards. It's important to realize that in Europe, an EN standard has a higher impact because you cannot have conflicting national standards. They have to be withdrawn by the national standard body if you have an European standard, not if you have an ISO. But EN ISO will have the same effect as an EN standard. So there has been a lot of work done on these standards. But they're mainly dealing with use of new buildings. What do you do with the existing? Many European countries, we have like 3% of new buildings every year. So one of the big issues now, how can we get better energy performance of existing buildings? And we need incentives. Building owner will not by itself do it. We need incentive like tax cuts or financial support. And the countries are now looking at plans how to improve the existing building mass. Now, when we look a little on the US, it's a little different how things are done, because you could see in Europe, a lot of this was directed from the European Union and then implemented by local government, and then there will be, in each state, there will be building codes that must be filled when you make new buildings. There's no, from the government in the US, there's no general requirements. There has been many bills trying to increase energy efficiency, but it's very much up to each individual state what they want to do. And one of the states which has the most strict criteria is, for example, California. In their standard is Title 24. One of the documents, when the state, they implement a building code and have some requirements to energy efficiency, a major of the states have, some states don't, they often use ASHRAE standard 90.1 as a reference. So this standard 90.1 has a big impact on the energy performance and the way to zero energy building. But there has been no general definition of zero energy building, so DOE had a working group looking at how to establish a national definition of zero energy buildings. I'll just come back to that. But one thing that, for example, DOE also initiated, and which I think can have a big impact towards zero energy buildings, is, for example, the solar decathlon. Some of you will know the Solar Decathlon is a competition among technical universities from all over the world to design, build, and operate plus energy houses. So there is a competition where at the end 20 universities, they build up here on the mall in Washington their houses, and they had to show that they are energy plus houses. Because we need in the future energy plus houses, because some of the existing houses we cannot make zero energy. So some of the new houses have to support existing houses. So I think in the future it will be easier to have zero energy communities than having all buildings zero energy buildings. So this was established several years ago in the US. The DOE initiated this competition. Now the competition take place both in Europe, China, also in the Caribbean. They have. So this definitely have an impact on the education of people and towards the zero energy buildings. So one of the big discussion when they were going to define zero energy building in the US was the what should the basis be? Should it be site energy, as I discussed before? Should it include the source energy? Should it be zero energy cost? Should it just be related to the cost? There was then this discussion, and as I mentioned earlier, the site energy is you can only take into account in the energy balance what is produced on site. But with the source energy, you also can take into account what is produced at the source. Is it a wind farm, which are doing a lot of the electricity production, is a big solar farm, or so on. And it was decided that the in the US, or the DOE definition, is based on source energy. So in principle, if your source has a lot of renewable energy in the mix, in the electricity mix, and is based mainly on renewable energy sources, then a zero energy building doesn't guarantee it's a very good building. It's just because you have a source that is using a lot of renewable. So in ASHRAE, we were more looking at defining it related to site energy, but it will be based on source energy. And that's understandable. If you think about big cities like New York or, for example, Hong Kong, Singapore, you don't have very much possibility to produce any renewables on site. You have very little small roof compared to the total square floor area of the building. So if you want to have a building to be zero energy building in big cities, you need to have include also the source. So an energy efficient building where on a source energy basis the actual annual delivered energy is less than or equal to the on-site renewable exported energy. So both source energy and renewable exported energy from on-site is then included when you do the definition of zero energy building. There's also required that the building, they must have demonstrated actual annual. So you cannot really be a zero energy building before you have done measurement for some time of the actual energy use. There are some other programs which also will improve energy efficiency and go towards low energy building. We also know the building sustainable certifications like LEED, BREEAM, CASP. There are many around the world, and that helps also to go towards zero energy building. But the requirements there are far away from zero energy buildings. I'll just mention a couple of things that, for example, how ASRE is trying to contribute to zero energy buildings, and that mainly through standards, handbooks, and we have what we call advanced energy design guides, where the standards, they are US standards, so they are used by the states, different states, or most of the states. Some of them are used also international, but for example in Europe, there has built up a completely different set of standards for the energy performance of a building. But the most important for ASRE is standard 90.1. There's work on a similar one, 90.2 for residential, but there's some other documents also related to energy performance. And we have also seen with 90.1, like we saw from the European building codes, that the requirements over the year will be more and more strict, so it goes again towards zero. It's not zero yet. To do it even better and to have more distribution, because standards, they cost money, ASRE also producing some free resources like the Advanced Energy Design Guides. That's a design guide that shows you how you can do better than, for example, standard 19.1. And there are these design guides for different types of building. Just released was grocery stores, but you have for schools and quick service restaurants. And now the discussion is, now that there is a definition of zero or net zero, that the future they were going to look at how to make a design guide for zero energy buildings. And these are all free. You can go on the ASRE website and you can download them for free. ASRE also has made an energy certificate, building energy quotient, in parallel to what has been done in Europe. So at the end, to get to zero energy buildings, we have to use on the energy use, efficient building construction, use passive strategies, and use efficient system and appliances. But there's one factor which we have not really dealt with in all this, and that's the user behavior, how people behave in their buildings. And if we don't look at that, we will never get to zero energy buildings. Here is an example of the influence of user behavior. It's 290 identical houses. They're built in Denmark, and we have measured here the energy used for heating over several years. It's similar houses, similar type of families. And you see how a wide distribution there is in the yearly energy use, all the way from down to 25 kilowatt hours per square meter per year, up to 150, 200. And that is because people are using the building differently. They have different set points for their temperatures. They may open the window more or less. And it will be very difficult to get to zero energy if we don't try to maybe influence the user and help them using the buildings in a more energy efficient way. So there's a lot of activities in research. There's also an annex from the International Energy Agency on occupant behavior in building. How can we model occupant behavior? For example, how can we model people's behavior regarding opening of windows, which has a big influence on the use of energy for heating in cold countries. So how can we get models that better prescribe how people are feeling or how people are acting? There are other things that influence people, how they act. Here, for example, is from two different apartment buildings. One apartment building, people, they were paying on individual heat meters for each apartment. In the other apartment, it was paid collectively. So they were just paid according to how many square meters their apartment were. And you could see in the temperatures they had in their houses was those who paid collectively, they had higher temperatures. That all the full lines here. They had significantly higher temperatures in their apartment than those who had to pay individually. So the way you pay for energy also influences the behavior of people. The same we could see with the CO2 concentration, that people who paid collectively, they opened the windows much more. They had much more ventilation than people who had individual metering. Again here, it's also important that we still keep an acceptable indoor environment. So in the future, when we now want to calculate energy performance of building, normally we have done it in a deterministic way. So when we put the input, set points and so on, we get one number for the energy performance of building. In the future, when we want to take into account people's behavior, we will have more a stochastic calculation. So for a building, we will get a distribution, a distribution of the energy performance. And then, of course, we should get it so the buildings are close to zero and that the distribution is narrow, because the narrow distribution means that it's more robust towards the influence of the occupant. So that's something we will see in the future. We may have to, want to take into account the user behavior, and that we will probably have more stochastic calculations than deterministic. So energy demand, energy efficiency, renewable energy sources, that is what is being focused on when we go towards zero energy building. Decrease energy demands, that has a lot to do with the building design. Increase energy efficiency has a lot to do with the HVAC system. And increased use of renewable has to do with the energy source. And definitely in Europe, we are looking very much on these possibilities. You can, of course, also start looking for new energy sources, fuel cell fracking, which will decrease the use, for example, fuel cell probably of fossil fuels. So the emphasis, what we have, what we do from ASRAE, but also what we do in Europe, is on the first three here. But there's one thing, when we talk about the energy efficient technologies, we have to look at the indoor environment. We can, if we don't take into account the indoor environment, it's easy to get to zero energy building. But we have to look at technologies which still provide, for example, a good indoor air quality. And that means for the ventilation, reduce the loads, use heat recovery, increase system efficiency. And we also talk about use of air cleaning and also personal ventilation, where you get the fresh air directly at the workspace. For the, when we talk about heating, cooling, again, reduce the loads by having a good design building, increase the system efficiency, and the trend is to use low temperatures for heating and a high temperature for cooling. And when we, at the end here, look at a typical office building and see what is the cost, we have talked about it should be cost neutral, or it shouldn't cost a lot of money to save energy. When we look at the cost in the building, and we put the cost to pay salaries or insurance for the people working there is a factor 100, then the energy to provide the ventilation and heat and cooling is only 1% of that. And that's the 1% we are talking a lot about to save on the energy, which we should. But this clearly shows that the buildings, they are for people. They are not for saving energy. Thank you.
We thank you for his speech, Mr. Brajne W. Olesen. Now we invite Mr. William M. Worek to present the plaque. Dear participants, thank you very much. This is the end of our first session. Now we invite you out for a short coffee break, and we will come back here for the second session after 10 minutes.
Bana çok gelecek ya. Biz teşekkür ederiz. Sağ olun. Sizlerin desteğiyle. Yani solar ve katılımlar çok önemli. Onun için özel görüşmeniz lazım.
Bir de bana gelse o neşe.
Zaten neşe çıkacak güzel.
Tam kameralardan kaçıyorduk geldi.
Tam kaçıyorduk ve yan yana çıktık gördüğün gibi.
Derim ki o benim kızım yanımdaydı.
Heyecanlısı benim.
Kolay gelsin.
İşte adam geliyor, bu işi siz yapacaksınız, bu fiyata yapacaksınız. Ben mevzuyum. Zaten çok daralsam aramızda.